Hi, I'm Mr. Huber, and in this video we're going to look at exercise 3a. Rewrite each function in factored form and find its zeros, y-intercept and vertex. Sketch the graph qualitatively. So let's start with the first one. F of x is x squared plus 18x plus 72. So now we need to write it in factored form. X and x. Okay, so this is the ansatz that we're looking for. I told you it's not always possible, but well, the first few are certainly possible here. So 72, that could be 1 times 72. It could be 2 times 36. It could be 3 times 24. It could be 4 times 18. 5 is not possible. It could be 6 times 12. 7 is not possible. It could be 8 times 9. And then it reverses the numbers. It could be 9 times 8 and so on. So we don't have to carry on. So now which one is it? We know this one has to be the product. Okay, so it could be each one of these. But then when you add them up, it has to be 18. So let's see. Not possible, not right, not correct. Well, 6 plus 12, that's it. So it's plus 6 plus 12. Now we have the factored form. Well, it's an original parabola. That's a good thing. So it has no vertical stretch or vertical shrink. We'll talk about that from exercise 3i onwards. Okay. Well, now we can work out the zeros. That's very, very easy because if you can write the factored form, it's very easy to find the zeros because x plus 6 and x plus 12 is 0 times x plus 12 is 0. So either this factor is 0, x plus 6 is 0, so that would mean x would be minus 6, or x plus 12 is 0, that would mean x is minus 12. So either you plug in minus 6 and that would satisfy this equation, or you plug in minus 12. Let's think that through. So minus 6 plus 6, that's 0. And then minus 6 plus 12, that's 6. So 0 times 6 is 0. So it checks out. The second one, minus 12 plus 6, that's minus 6. Minus 12 plus 12 is 0. So minus 6 times 12 is 0. So that checks out too. So these are the zeros of the function. So now you can, in fact, make a qualitative sketch like this. Here we go. So let's say this is minus 6. And let's say this could be minus 12. Okay? So what we know is that the vertex has to be in between these numbers. Okay? The vertex has to be in between these numbers. So it's minus 6 plus minus 12 divided by 2. That's minus 9. So it is going through minus 9. This will be minus 9. That will be the x value of your vertex. X value of your vertex. You could work out the y-intercept. Well, that's 72. 0, 72. Well, that's very high up. That's probably not. That's too high up here, okay, for the moment. And then let's work out y v. Well, you just plug in minus 9 into this or this function. I think it's much easier to plug it in here. So that would be minus 9 plus 6 and minus 9 plus 12. So this would be minus 3 and this would be 3, so it's minus 9. So apparently it's down here somewhere, minus 9. So this is what your graph looks like. Here we go. Like this. And it would eventually intersect the y-axis at 0.72, but you can clearly see that's too high up for our drawing at the moment. But, well, the y-intercept is 0.72. This is your vertex. It's minus 9, minus 9. And your zeros. So you know everything about this graph. If you wanted to draw it like this, you could say, well, this is your 72. Then you just do something like this. Let's try and hit that 72 here. This would be minus 9, minus 9. This would be minus 12, and here minus 6. Here we go. Then you would have everything on your drawing. Well, this was quite a good drawing. This is just a very fast qualitative sketch, but the good thing is I can see it intersects at 0.72. But this is a much nicer sketch, but I can't see the y-intercept in this case. So that's the disadvantage. Okay, so I hope it wasn't too difficult. See you in the next one.